Welcome to another episode of TeqTalk, where we discuss tech and industry in a most fascinating way. I'm your host Jas, and today's episode is very special because we are diving deep into the world of AI agents and how they are revolutionizing the world of manufacturing. To join me is a very special guest. His name is Ravi Ravichandran, and he has got immense experience in SaaS, Salesforce, and of course in manufacturing. So let's get started. Hi Ravi, how are you today?
I'm doing fine, thank you. Thank you for inviting me.
Thank you for coming and joining our podcast.
Appreciate it.
Yeah. So let's start with our discussion. And today's topic is a very hot topic, and we are going to talk about AI agents, especially in the manufacturing.
Okay.
Yeah. So AI agents, they are nothing new, right? They're popping up in every industry, and manufacturing is nothing new. So from your vantage point, what do you think these AI agents are and how they are making a drastic change in manufacturing, both in the technical side plus in the functional side?
Thank you. It's interesting. Probably manufacturing is one area that is lagging behind from a technology adoption of AI. Manufacturing is usually conservative, and they are waiting and see how it's going to work. So from the AI perspective, the areas that could help them, I would say ML plus AI, I would put it that way, is that one, it can help manufacturing to have a preventive maintenance and predictive analysis. And secondly, improved efficiencies, process efficiencies. If you have complex processes that could be simplified and analyzed, and it could help. Yeah. And then the third one is from a supply chain point of view. If you can predict what happens if a supply cannot make it, or if orders have to be redistributed, how it could be done from global perspective as well. And then the last one is the actual manufacturing itself. Yeah. So the way that currently the manufacturing is done, it is basically machining. You take something and you whittle it down. The modern techniques are usually additive manufacturing, particularly like a 3D printing. So these are the areas manufacturing could benefit from. And one more area which is non-manufacturing, which is specifically customer support and other areas where agents will come in effectively.
Yeah. So one very good example is Siemens Stamber production plant. They have created AI agents, and they are handling around 75% of the whole production processes without any human intervention. So isn't it amazing? I mean, if you are increasing your efficiency and reducing your cost and making the material, the output is amazing, strong as well. So that sounds really fascinating. What are your thoughts on that?
Very interesting to know. So those kind of areas where robotics are coming to play, it helps in multiple ways. One, it removes the repetitive injuries that workers face. And also it helps areas where you probably have high chances of injury. It helps in that area. And then the third one, it allows you to combine what the workers are doing, the robots and workers. It's called cobots. And so it helps them in fine-tuning the work that they should be able to do. For an example, I saw where a person is sitting there and there is a attachment on the hand. So when the worker is lifting, they are not actually fully lifting. The other systems are helping them over there.
Easier.
It is not like a skeleton thing, but it's a minor variation of that. So these are the ways in which the ability to manufacture efficiently, effectively, without injury is coming into play. So, an example of that, I would say, is this how Tesla has done successfully.
Absolutely.
Initially, when Tesla started, it had a lot of workers. I can specifically talk about the Fremont factory. And then they found out that the productivity could be improved by having robots. They tried general purpose robots, and then they found out that the robots were, while it is effective, it is not most efficient. And what they did was they created a specialized robot just for themselves. And so in the process, they were able to streamline the work of how quickly you can manufacture a car. And also, I'm repeating myself here, they were able to help the workers employees to reduce the strain on manufacturing cars.
Absolutely.
Most difficult one, the robots could help them. That's what it is. So they were able to do that, and they continually improve on their robotic process where they have higher efficiency of producing the cars in a line as quickly as they can.
Yeah, they can detect the failures in advance, making it much more efficient.
Yeah.
So do you see somewhere like 5 years down the line or so that robots are only handling everything down on the manufacturing side? Is there something you think can happen?
Potentially, yes. If they can land a rocket on a Mars,
Yeah.
okay, and there is a last 20 seconds that particular payload has to land on Mars surface, and in real-time telemetry decision has been made as to where it's going to land.
Wow.
Okay, is in less than 20 seconds at running around, I don't know, maybe 100 miles an hour, and it has to make a determination where it has to land and course correction. If they could do it, yeah, probably in 2025 you could do it. But having said that, the rate at which the AI is changing, it is potentially possible, but it is very difficult to say what is going to happen in 2025. Mm-hmm. What is available today is getting changed every 3 months.
Absolutely.
And it's difficult to say what's going to happen in 2025.
It is evolving like anything, right? It has never evolved like this now.
Exactly.
All right. Thank you so much for such insights. And what is the best way to start any AI journey or AI agent journey? Talking about it and writing it on paper sounds much easier, but when it comes to actually adoption, what do you think are the best practices any manufacturing company should take into consideration before they start the use case or start the implementation?
Yeah, start small. That's what I would say. The way you go about is identify your pain points, the most critical pain points that you have, and identify what it takes to complete that. What is the exit criteria for the pain point, right? And once you have done that, you go to the next step. How do I prove my ideas with regard to AI is fruitful or not? And you would start with a MVP or a POC. You will work with it. My recommendation is work with the POC that is as fast as you can.
Yeah.
Probably 4 weeks, maybe 6 weeks. And then have a checkpoint and see is it what you are trying to do, what it can accomplish or not. And if you have to pivot, you may have to pivot it. And this is a rapid prototyping process that you have to use.
Yeah.
And once you identify it is valuable, then you extend the POC to probably a minimum viable product. And then you have to have the ability to execute it within between 3 and 6 months of your vision. Okay. Yeah. This is not long execution times and planning required. So start small, increase the velocity, and increase the scope.
Absolutely. That was my next question, which I wanted to ask, that the enterprise organization, right, those who are very big in size and they already have legacy systems, they already have multiple hyperscalers inbuilt. So when they start adapting any AI initiative, they easily take 1 year, 2 years down the line. But this is not the case with a mid-size organization. So if you consider mid-size manufacturing, so great value, like how you mentioned that take the use case, identify your use case, start slow and try to get the quick turn around within like 2-3 months and see if it is really benefiting you. So if it is not, then pick up another use case, make sure that it is aligned with your industry and aligned with your business, and then see how it is changing the ROI.
Also, learn from your mistakes.
Yeah.
So you thought that was a problem that could be solved. Maybe it can't be solved, right? And go find another problem that can be solved. So I think from a C-level perspective is that if you show a win, there is more budget coming in.
Right.
So don't take the most difficult problem and say, I'm going to solve it. Take a problem that is solvable and show a win, and then take the next difficult problem.
Yeah. In the manufacturing sector, what do you think, where are the problems lying and where are the scope of putting on automation and AI agents?
I would probably think areas where if we can reduce the defects and failures, that will be a good one, because this is where your IoT devices come into play. And if you have a streaming of information coming from big data is available, and if you are able to predict the failure rates and then do a preventive maintenance, then that's a win. And the other one is ability to take information from different systems in place. I typically use the word customer 360. You could use the similarly manufacturing 360. This is where your information is from a manufacturing, planning, execution, and the procurement and the supply chain, and all those things put together. If you have a full visibility of a manufacturing, then a right set of technologies that allows you to say, if something happens on supply chain, what happens to the order fulfillment? Or if there is a defect in a product that you need to have an engineering bomb done and needs to be executed so that you can have a product ready to be built. All those things can be simulated and realized, and you can act upon it. That would be one area where AI will be helpful.
Absolutely. And once any organization start working on and start implementing AI, what are the hurdles you can see that, okay, these are the things you really need to work on before actually starting your work? So if there are any best practices or recommendations from your side.
So if you already have a system in place, particularly enterprise application in place, that would be a good start. I'm going to throw some name like Salesforce. And so they have a solution, both horizontal and vertical solution, and leverage what companies like Salesforce provides from AI perspective. They've gone through this process of one, securing the data, and then they want to make sure it's available through the prompt engineering, and then also the ability to bring the data from various sources to have intelligence over there. So if you already have one like that, leverage it, or identify technologies in marketplace that is suitable for specific purpose. For example, LLMs are useful for certain things, and you could use, if it is LLM is the right answer, right? Or if you have a predictive intelligence that needs to happen, that requires modeling, and there are modeling tools available, Vertex AI, SageMaker, you name the tool. Use those modeling tools out of the box, and take the existing libraries also out of the box as much as possible, come up with a win, and that would be another way to look at it.
That was very insightful. And what are your insights on the data, right? Manufacturing companies, and this is not even manufacturing company, it's regarding all the companies, they get data from any and every source, right? Now, data is present in silos and fragmented systems. What are the recommendations you'll give from your side to make sure that data can be really used for insightful decisions and for insightful actions? Is there any best practice which can be leveraged for making the data concrete?
That is why data lakes are there. Okay, there's a temptation to say, I'm going to make my own data lake. Okay, if you're capable of doing it, you can execute it, it's good. If you're a mid-sized company, your focus is on manufacturing the widgets and not data lake, right? So look at the data lakes that are available in the marketplace, and then bring the data from various sources. They provide the connectors, Excel connectors and SQL connectors and any kind of connectors that you want, and bring the data into data lake, and then model it the way you want it. And then if you want to have a prediction on top of that, there are tools that are available to be used on top of data lake, right? If you want to have business intelligence and reporting, data lakes can do it. But the minute you go into the deep end of a machine learning, then many data lakes do not do that. Maybe there are some few that claim to do it, but if that is a point, then all you have to do is do not recreate the data, point your machine learning systems on top of the data lake, and then you can run your business on top of that. In order for this to happen, cleanliness of the data is very important.
Absolutely.
And people usually get enamored by the technology, just go to the technology. But what you end up with is that the systems do not have the right data and not cleanse the data. And our focus should be on cleansing the data first, before you go to the next step of, okay, what systems I'm going to use to get the prediction.
Yeah, absolutely. I think data is the foundation of everything. Data is the foundation of AI. Data is the foundation of any actionable insight they are going to take. If the data is good, you're going to have good ROI. If the data is not good, you're just doing any random stuff. So what are the best practices? What do you think? How can any company clean the data? In the enterprise organizations, which I have seen mostly, that there are so chunks of segments and verticals are there that people are only aware of their data type. They are not aware of how the whole data is flowing from one system to another. So what should be their kind of understanding on data and how they can really refine the data in a cleaner way?
So common terminology is a common data dictionary. Enterprises do it. Larger enterprises, that's where they work because they have multiple disparate systems.
Yeah.
So there is a data governance that you cannot go create more data unless it goes through the governance process.
Yeah.
But however, if it is small enterprises, they just have to go with what you got. Then you have to come to a point where you have to document what you got and rationalize it, and you cannot make changes to the system because systems are running. So what you have to do is you have to do the ETL where you extract the data and transform the data and load it into wherever it is. In order to facilitate, you need to have a common data dictionary, and that's a part of the governance cycle that needs to happen. And once you have that, then you unearth the challenges between systems and how the data have been defined, how it needs to be normalized. And that's the challenge. And the answer is start small, take maybe one area of manufacturing, maybe procurement, maybe or a supply chain, maybe it is a quality, or maybe it's engineering. You take one area, refine it, and find the processes and find that it's a set of technologies that need to leverage, and then expand the scope.
Yeah, absolutely. I think data plays a very, very important role. Would you also like to talk something about data ethics? And there are a lot of biasing and non-transparency things are happening around data. So what are the things any organization should keep in mind to make sure that the ethics are kept intact?
Very crucial point. That is where enterprises, initially it wasn't there. The vendors that had LLMs, for example, they trained on your data. And now they have realized that it cannot be done. So there are two ways to do it. One is you have a specific contract with the vendor that they cannot train the data, they cannot remove the data. Or you make sure you anonymize the data before you go into the systems, any one of the machine learning systems, and they don't get trained on your data, right?
So you mean to say there should be some guardrails, there should be some kind of masking, and from the organization level, there should be some kind of auditing done to make sure that, or the rules done to make sure that the data is kept in a very, very private manner.
It is obfuscation, anonymization, and PII. Don't send a PII. That's the first rule, right? And even if you had to do it, you have to do it in such a way that the systems cannot learn. And the first thing would be get a contract that you don't train your data and then you don't remember the data. And second is, if that's not possible, you have to protect the data, and there are many means when you can do it.
Yeah, absolutely. Let's talk about technology now. So technology is evolving almost every day. Something new is coming up, right? So for any manufacturing organization, how would you suggest that what technology stack they should start working on if they are starting fresh?
I would say LLMs. That's where the easy wins are, because LLMs have been trained on the text available solutions available in they can scrounge and get the data back, and they are very good. And start with LLMs, and also start with vector databases. They are very semantically, the search semantics are very good, and so a combination of LLMs and vector database will be a good starting point. And come up with a way you engage with your end customer, end users. Anything that you do, execute, it has to be in place where they live every day. if it is email, or if it is calendar, or if it is inside the enterprise system, or any Slack or any other systems where they live, that's where the intelligence have to live. You cannot take it away from them. So in that way, one, you reduce the friction for somebody has and say, tell me more about it. So the systems can quickly find out from various places and bring the data back and summarize it to them.
Yeah.
What are the purpose of LLMs? So the summarization, okay, next best action, and create actions, create an email, create a task, create a follow-up, set up a calendar. All those things can be done with LLMs, and that's where a good starting point.
Yeah, that's a very, very valid point you have mentioned. And a quick fun question I have for you. Given a chance in 2025, if you have to start your own manufacturing production, what will be your favorite technology stack and how you'll get started with it?
Oh, that's going to be a tough one. The systems are changing, the technology is changing so fast that it is very difficult to say that. If I have to stick my neck out, probably I would say come up with a manufacturing plant that is adaptable and a future looking. Example of that would be, I would say, Tesla's mega plant, battery factory, where they started with certain set of technology, and then they found out that this technology that they had for battery manufacturing was no longer the right one, and they pivoted to the newer one. Okay, so flexibility while you are designing, and also have the ability to have information flowing readily from machines to systems. Think of IoT, and think of IoT where not only it sends the information, it should be able to get it fixed. Again, I'm going to Tesla as an example. When Tesla does a recall, it doesn't mean you need to go to a dealership to get it done. It does it overnight. When you say get it done, it makes the changes to the system. And next day morning when you wake up and says, I've done the following things, you would like to look at it, right?
Oh, wow. Yeah.
So that's what I mean by IoT.
Yeah. So Tesla is kind of pretty advanced. So that is your dream, and that will be your favorite kind of road path.
That's your North Star.
That's how you should start with.
Yeah, that's where you're looking at it.
Yeah, absolutely. So from your experience so far, what is the craziest thing you have seen in manufacturing which has evolved so much? I
would give an example of Ford. I was at a convention, I would say about 5 years back, and they talked about additive manufacturing.
Okay.
Industry 2.0, they're talking about...
Tell more about it.
So the idea is this: when they looked at it and say this is what they manufactured, and then you whittle it down, and what happened to the scrap, right? And if you have to redo it, and then you have to start with a chunk of block and then redo it one more time, then they came up with additive manufacturing. So, which is a 3D printing. So they started 3D printing with the plastics, and then they started 3D printing with alloys, and then they went to the other materials. So what they're doing is, in the process, they are experimenting in small scale, and once they perfect it, what you get out of the product is no machining required. It comes out of that solution as a product. That's the one. And then they turned around. Another was Ford 150. They went from steel frame to aluminum frames. Everything was aluminum. And in order to do that, the welding process that needs to happen on aluminum was not perfected. So they had to go and redo an engineering so that the reason they had to go was it reduced the weight on the Ford 150. And because of that, it increased the fuel efficiency. That's the reason they did it, right? And also anti-corrosive of this materials that goes over there. So answer is, I looked at Ford 7 years back, and I looked at this, that's great. And that's the way visionaries look at. Yeah,
that's a very, very good example. Thank you for sharing all that.
Sure.
And what do you see manufacturing industry 5 years down the line? Where do you see them? You can take two examples. One is for the enterprise, and second is for the mid-level companies, those who are picking up the race. What do you see 5 years for them?
One area I can think is that the ability to simulate a product creation Okay. I consulted with the company. They have a plan where if you're going to produce a product, that product has to be produced through a simulation, and it has to go through including the cycles for testing in the simulation. And when you produce a product, it is a perfect product without actually manufacturing a product. Okay, so that's where these things are going. So you think of a product, you come up with how the product needs to be built through simulation, and you end up with the product which actually is manufactured in the factory floor.
Wow.
That's where things are going.
Yeah, that's pretty interesting. So what is the practical advice or recommendation you'll give to our executives, those who are going to start with the AI journey?
First, AI is here. It is for real. It was fun for some time. People were experimenting. But today, it is real. And the C-level people who are not behind it, they are probably going to get left behind. And the competition who takes it will win over that. The second is find areas that is comfortable. Okay, I'm going to go off subject. Not only manufacturing, it could be beyond manufacturing. It could be in finance and accounting, right? And I'm going to go off subject here. For example, there are systems where they can look at a piece of paper and determine what should be the journal entry it should make. It can eliminate the need for somebody to look at it and say, I need to define this journal entry to be debit and credit. It has to be done. The systems can do it automatically. Okay, that is not manufacturing. My point is that find some areas where you have efficiencies that could be created with ML and AI, go at it first, and then pick the other battle. Pick a battle that is winnable, small, and you can show you have a success, and then pick the next battle, and don't pick up the worst battle as the first item.
Yeah, absolutely. Great words. And with that said that, we would like to wrap up. Thank you so much, Ravi, for your presence and for your insightful experience. It was really, really amazing.
Thank you for inviting me.